All right, students, we're back to old school here. We're going to do some screencastify in regards to our lesson today. What we talked about in previous classes is the general formula for what we know right now is y is equal to a sine or cosine of b theta, where the amplitude is equal to the absolute value of A. The period is equal to 360 divided by B. When we have a sine curve, we start on the neutral axis. And when our graph should look like neutral axis, up, down, back up again, that should be your typical sine curve. And when you're dealing with a cosine curve, we start at peaks and valleys. So if I look at my graph, I will start at my peak or my amplitude down and back up again, or it could be a valley where I start at the bottom, go up, and then back down again. And once again, if we have a negative sine curve would just be SpongeBob opposite day, the opposite of what we're dealing with. So this is typically what we've been working with up till now, to be able to ease in regards to the graphs and graphing of our sine and cosine functions, because plotting a lot of points and plugging in a lot of points and finding y values it becomes very time consuming. So we're trying to make life a little bit easier on ourselves. Today, what we're going to talk about two things. We're going to talk about phase shifts. Okay, when we're talking about phase shifts, it's the sliding of your amplitudes. When you're in algebra, or sliding of your graphs. When you're in algebra, you worked with what was called translations. Okay, when you slid the graphs upwards or downwards or to the left and right, that was called a translation in algebra. But now when we start talking about sine and cosine curves, and a lot of things turn into sine and cosine curves. Electrical currents turn into sine and cosine curves. What we deal with then is that's called a phase shift. We have a phase shift or the sliding of the graph. So when you're dealing with phase shifts, we're just talking about basically translations. So when we're dealing with phase shifts, we have translations, which is the slide upwards and downwards, or left and right. So we're sliding our graph upwards and downwards, or we're sliding it to the left and to the right. And in the trigonometric world and with sine and cosine curves, this is called phase shifts. Okay, we're going to go start out old school wise in regards to how we did our initial graphs. Here we have the sine of theta plus 30. So we are taking the sine and we're looking for these values here. A value negative 120. We're putting negative 120 in and we're calculating a y value. Let's see here. Let's look at our graph here. I'm going to space out by 90s. So we have 91, negative 180, negative 90, then space out by 90s, 180, 270, 360. And what we're going to do with this, with these graphs or with this axis, once again, label your axes, is we're going to divvy these up into thirds. So I have 30 and 60 there. And I divvy these up as best as possible into thirds. And once again, you try to do the best you can. It may not be perfect, like my gap here from 180 is not very good. So I'm going to spread that out just a little bit more. And you divvy them up into thirds. Once again, getting a graph down and getting your spacing in your graph is an acquired thing. It doesn't happen overnight. but you tend to get better and better as you go along with respect to your graphs and the spacing of these graphs. My amplitude is 1, so I'm just going to go up. I'm going to go up 1. I'm going to count up 2. 2, 1. Then we have -1, -2. Now, when we find our y values, I'm putting -20 in, -120 in, and adding 30 to this. So I take -120 plus 30, that gives me a -90. So I'm going to take the sine of -90. If you want to quantify that, that is fine. You can quantify the sine of 120 plus 30. If you want to do some mental math, and say that's -90, looks like my calculator is not working. Oh, well. I guess I can't show you that. So in your calculator, I want you to find these values, your y values. Find your y values. Keep doing your values. I'm just going to fill in the values as you work. As you read down the column, you should have -1, -0.87, -0.5, 0.5, 0.87, then 1, 0.87, 0.50, -0.5, -1, and -0.5. So if we start looking at the graph of this, we have a sine of -120 is -1. The sine of -90 is 0.87. -60.5. -30, we're at 0. At 0, we are at 0.5. At 30, we're at 0.87. At 60, we're at 1. 90, we're at 0.87. 120, we're at 0.5. 150, we're at 0. 180, -0.5. 240, -1. 330, -0.5. Oopsie. 240, we're at -1. 330, we are at -0.5. I'm sorry, 360, 330 we should be at. We should be at 1 or 0, my bad. This should be 0 here, and at 330 we're at 0 up here. So if we take a look at this graph, my graph looks very similar to a sine curve. Now what I'm going to type in here, or what I'm going to tap in, is if I did a normal sine curve, at 0 it would be at 0, at 90 we would be at 1, at 180 we'd be at 0, 270 we'd be at -1, and 360 we would be at 0. So if I looked at my normal sine curve, this is what we have. Now if we take a look and make a comparison to the normal sine curve, what has occurred? What has occurred to our normal sine curve? Well, our normal sine curve was this right here. And all we have done is we've moved it over and we slid it over to the left. And when we slide it over to the left, we take a look how many degrees we have slid it. Well, if I take a look at every point that we're working with here, we have slid it 30 degrees to the left. Every one of our points has been slid 30 degrees to the left. What this is called a horizontal phase shift. And if we take a look at our equation, we have y plus 30. And if we have y plus 30, that tells us what our horizontal phase shift is. But the problem we run into is going to the left, which is typically a negative thing. So how we correct this, or how we deal with this, is we take a look at, and this is called a horizontal slide, just a horizontal slide. We can alter our graph or our equation to y equals, and it does not matter if it's sine or cosine, theta minus this horizontal phase shift. Whatever is being subtracted from theta is the value that we're going to have as a horizontal phase shift. Well, you might sit there and look, well, Mr. Gregory, well, this is theta plus 30. I'm not subtracting anything. Yes, we are subtracting something. I could rewrite this as theta, and I call this a ching boom. We have theta minus a -30. We are undoing the subtraction, or undoing addition and making it minus a subtraction. So the value that we are subtracting off of the value of theta is a -30. And that's what we take a look at. So it's sort of the opposite sign. Well, if we take a look at another one, and we could go through the ordered pairs if we want, but let's utilize this idea now. Our amplitude is a value 1 because our coefficient there is 1. The period is still 360 degrees because I have no coefficient to the b value, or a value 1 there. But now we have a horizontal phase shift of what's being subtracted off of theta. And what's being subtracted is a value of +60. So with this +60, that means we're going to move our graph 60 degrees to the right. Now we could set up a bunch of ordered pairs, but let's use our knowledge that we gained on Friday and today to be able to get a graph down. We have theta and we have y there. This space out by 90s, 90, 180, 270, 360. And if I want to, negative 90 back here. Let's just space up 1 and down 1. And let's divvy these up into thirds. Typically with a cosine curve, we start at a peak or a valley. And the peak is the amplitude, as we talked about before. But if we take a look at our graph now, what we have to factor in is this horizontal phase shift to 60 degrees. Typically, we would start up here at the peak at 1. But since we have a horizontal phase shift to 60 degrees, that means I need to move this point to the right to 60 degrees. So my peak now slides all the way to the right at 60 degrees. And I'm probably going to need a little bit more space down here. Correct. Because I'm going to have to go out to 450. Now we start at a value of 60. By definition, the period is the number of degrees in a cycle. The number of degrees in a cycle. I go 360 degrees. A cycle is a portion of the graph to another portion of the graph where the graph starts to repeat itself. If we start at 60 degrees, every 360 degrees, we will be at the exact same spot. So if I start at 60 with my graph being a peak, I need to go 360 degrees from this 60 degrees to find my next peak, or my peak for my cosine. So if I start at 60 and I go 360 degrees to the right, what degree measure would we be at? That's exactly correct. It would be 420 degrees. At 420 degrees, I need to be at a peak again, because this takes us 360 degrees. So if I start at 60 and I go 360 degrees out, I'm at a peak. Between any two peaks is a valley. Now we play our games of halves. So halfway between 60 and 420. Remember how we talked about on Friday, how do we find the halfway point? We add the two numbers together, divide by a value of 2. So I take my 60 and 420, add them together, divide by 2. So we add them together, 60 plus 420 is 480. And take 480 and divide that by 2. And we should get 240 degrees. So at 240 degrees, between any two peaks, we will have a valley at -1. Between a peak and a valley, or a valley and a peak, we will be on the prime axis with the cosine curve. So we play our games of halves between 60 and 240. Add them together. We get 300 divided by 2. We should get 150. We'll be on the prime axis. And then between 240 and 420, add them together, we get 660. Divide that by 2, we get 330. So if I look at my cosine curve, Here's my cosine curve with the phase shift of 60 degrees to the right. Make sure everybody's good. All right, let's go to the back side. Now we're going to talk what is called a vertical phase shift. Which is a slide up and down of your graph. If we once again space these out by 90, and we're going to have to count up, let's count up 4 spaces along the y-axis. What I want you to do is I want you to now type in 2 plus sine of negative 90, 2 plus sine of 0, 2 plus sine of 90, and find your values. And plot their ordered pairs and get a graph down. Where we have 1, 2, and 3 if we go down our columns. Then we have 2, 1, and 2. And if we take a look at our graph, at negative 90, we are at 1. At 0, we are at 2. At 90, we are at 3. At 180, we're back at 2. 270, we're back at 1. And 360, we're at 2. So looking at the graph, it still looks like our typical sine curve. Now, once again, if I would throw in just a regular sine curve, I would start at 0. 90 would be a peak, 180 we're at 0, 270 we would be at a valley, and 360 we'd be on the prime axis. So this would be your typical sine curve, y equals sine of theta. Now if we take a look and compare these two graphs, a question I have for you is what has happened to our graph? Well, rather than being at 0, we're up at 2. Rather than being at 1, we're up at 3. Rather than being 0, we're up at 2. Rather than being at negative 1, we're up at 1. So in each one of these points, we have slid our graph. This is our sine curve. We have slid our graph up 2 positions. This is what is called a vertical phase shift. Now the vertical phase shift if we take a look at our equation, is right out here in front. So we have y is equal to vertical phase shift plus or minus our amplitude. We can deal with sine or cosine. B times theta minus our horizontal phase shift. But for us right today, just worry about the vertical phase shift and the horizontal phase shift. And this plus 2 is what's out here, a plus 2. Now, what this vertical phase shift will give us is this will give us what I call a prime axis. Now, this prime axis is going to help us and assist us with our graph. If we look, we are oscillating about the line y equals 2. So we're oscillating about this line right here, which I will call a theta prime axis. Now, the ramifications of that and the impact of that is, if we take a look from this prime axis, we go down 1, we go up 1. We go down 1, we go up 1. So we are dealing with our amplitude here, which is a value of 1, and we're going up and down from our prime axis. So the vertical phase shift will tell us where to put our prime axis at. So if we take a look at a graph, we have y equals -3 plus cosine of theta. The period is still going to be 360. Our amplitude is a value of 1. We have no horizontal phase shift. Our vertical phase shift is a value of -3. So if I space out my graph, I'm going to count out my 90s again. And I'm going to count down 4. I can go 5, it doesn't matter. The first thing that we want to draw in our graph is we look at our vertical phase shift. At -3, this tells us where to draw the prime axis. So at the value of -3, I'm going to draw in a theta prime axis. This is an axis that we will go up above or down below. We will oscillate about this. Our amplitude will be 1 from this prime axis up or prime axis down. We have a cosine curve. When we deal with a cosine curve, we have either a peak or a valley. Well, since we have a positive amplitude, we'll be at a peak. So from our value of -3, we have to go up to a peak, which is our amplitude. So if I start at -3 and go up 1, that's going to take me to -2. I have to go up 1 for my prime axis. The second thing we take a look at is the period. Second thing we take a look at is the period. This tells us that number of degrees away from 0 will be at the exact same spot again. So at 0, we're at -2. So if we go out to 360, we have to be at -2 again. Now our games of halves, halfway between 0 and 360 is 180. Between any two peaks, we'll be at a valley. So we have to go down from our prime axis a value of 1. So at 180, we're down at -4. Halfway between 0 and 180, between the peak and the valley, we will cross the prime axis. So between the peak and the valley at 90 degrees, the games of halves will put us at -3. And halfway between 180 and 360 is 270. We have a peak and we have a valley. We'll be on the prime axis again. So here is our y equals -3 plus cosine of theta. Take a look at the last one. We have our amplitude is still 1, the period is still 360. On Tuesday, we'll start combining all these things together. Our vertical phase shift and our horizontal phase shift. Our vertical phase shift is out here, the constant's being added on. So our vertical phase shift is 2. Our horizontal phase shift is what is being subtracted from theta, which is 30 degrees. So if we take a look at our graph, our y-axis, we're going to space up 4. On the horizontal axis, our theta axis, we're going to go out by 90s again. And we're going to divvy these up into thirds. Once again, you'll get better at this. First thing, vertical phase shift, we draw on our prime axis. So at a value of 2, at a value of 2, I'm going to draw on my prime axis. The second thing we take a look at is where do we start at? I think I made a mistake in the first one. We have a sine curve and a horizontal phase shift. This will also give us a theta start value. What value of theta will we start with? We will start at 30 degrees. Like I said, I made a mistake up above. So we look at our trig function. That will tell us, do we start at peaks and valleys or prime axis? We then look at our theta start value. That will tell us what degree of theta we will start with. So at 30 degrees, because this is our theta start value, sine tells us to start on the prime axis. So at 30 degrees, I will be on the prime axis. The third thing, we take a look at the period. 360 degrees will be at the exact same spot. So if I start at 30 and I go out 360 degrees, we will be at 390. And you can always take the period and just add the vertical phase shift to it. We will be at the exact same spot at a value of 2. Now we start playing our games of halves, halfway between 30 and 390. Add them together, divide by 2. Gives us 420. Divided by 2, we have 210. We're going to be on the prime axis again. Halfway between 30 and 210 is 240. Divide that by 2. Gives us 120. We're going to be at a peak, because once again, we're going to climb the hill and then scream. Halfway between 210 and 390. Add them together, that's 600. Divided by 2, 300. We will be at a valley. And there's our graph. Once again, on Tuesday, we will start combining all these ideas together and changing the amplitude and changing the period. And there'll be, once again, a cues that we will continue to work with to solve the problems that we're dealing with respect to graphs of sines and cosines. Your homework is on page 48, 3 to 12. That's your homework. Once again, the amplitude and period, I think, are pretty much the same throughout on all those, for most of them. You're mainly working with vertical and horizontal phase shifts. So get the information down that you need to. Get your graph down. Continue to work on your spacings on your graphs, because I know that's a difficult position or difficult thing for students to acquire at times. Work on your spacing of the graphs and try to get better at it. Tuesday, we'll come together and we'll start dealing with all these things together. Other than that, I have nothing else for you. You folks have a good day.